So we have a question on the board under factors affecting resistance of a wire or a conductor. Now it says, what is the resistivity of a cylindrical material wire whose 1 meter length has resistance of 2 ohms? The diameter of the wire is 0.5 millimeters. So you are seeing resistivity, you are seeing the nature of the material, the shape is a cylindrical material and it's a wire. Now quickly we run to the formula which we got as R is equal to rho L over A. But the question says, what is resistivity? So we are looking for resistivity, question mark. And if you make resistivity the subject of the formula, we have that rho is equal to RA over L. RA over L. RO, the resistance of the cylindrical material was given to 2 ohms. So RO is equal to 2.0 ohms. While length of the material was given to be 1 meter. So whose 1 meter length? So the length of this material, cylindrical material of consider is just a unit length of meter, 1 meter length. Now, area was not given about the material, about the wire, but diameter of the wire was given, which was D was equal to 0.5 millimeter. Now, note for every other quantity are in SI units, while diameter is in millimeter. So to convert diameter to meter, we simply divide it by 0.5. Dividing it by 0.5, we divide this in 0.5. That 1000 is standard form. We have a 5 times 10 raised to the power minus 4 meter. So that is the diameter in the SI unit meter. We convert millimeter to meter by simply dividing it with 1000. Now we don't need diameter, we need area. But from our diameter, we can get area. Take note, the wire is a cylindrical material. Now we know the shape of a cylinder, something of this nature. Now if we want to get the cross-sectional area, it's just looking at it from this part. And the cross-sectional area, the shape you are getting from this part is a circle. So to get the cross-sectional area of this wire, it's still the same thing as calculating the area of this circle. So calculating the area of a circle is still the same thing as getting the area of this cylindrical wire. And the formula for area of the circle is A is equal to pi r square. A is equal to pi r square. Where r stands for radius of this circle. The radius was not given, but the diameter was 50. Now we know that radius is half of diameter. Radius is half of diameter. R is equal to D over 2. So R is divided by 5 and 10 raised to the power minus 4 over 2. We now write our R is equal to 2.5 times 10 raised to the power minus 4 is under 4 meters. Now we can go back to the formula. Now this rho now equals to R times, so we cannot give it the area. We write the formula for area, then we have R square over length. Over what? Length. Rho now equals to our R is what? Our resistance of the initial wire was given to 2. And pi is given to 22 over 7 times R is now divided 2.5 times 10 raised to the power or 12. 1.5 times 10 raised to the power minus 12. So the arrow is carrying 12. Over nothing continues to be 1. Let me divide our 1 that is number. So 1 goes to the next line. Arrow 1 is 4. Rho stands for 22 times 5 square this. We have 6.25 times 10 to the power minus 2. Now 2 times 22 we give us 44. Divided times this times 44 over 7. 1 is not like that 1. Now everything here times 44 times 44 divided 7. 32 times us 3.9285 times 10 to the power minus 7. Now I'm making it to 2 decimal places. 3.923 times 10 to the power minus 7. And the unit as we know for resistivity is 2 meter. 2 meter. Once again, this is the formula. When you make resistivity the subject of the formula. I already see arrow here. Area of the wire was not given, but we said area of the wire is the same thing as area of the circle. Looking at it from the cross-sectional part, the area of that circle tell you how far the wire is, the area of the wire, it was pi arrow square, and we got our arrow from the diameter that was given, that dividing it by 2. And don't forget, the unit of the diameter was given to be millimeter. We have to first of all convert it to meter by dividing it with 1000. And once we divided it with 1000, we divide it by 2 again to give us the radius. And with that, we are good to go. And the formula for resistivity was this. We change this from this to this. We can go out the area. Area was not pi arrow square. Arrow was this. Pi is 22/7. And arrow which is carrying the square. This value was the value for r. And because it was carrying the square, I had to place brackets. Squaring it, you arrive at this in standard form. Dividing it by 1, dividing it number by 1, see that same number. So 1 had to go. So 22 times 2 was 44 over this 7. Then times this with this and divide it by 7 in standard form, which was this, as simple as that. As simple as that. Let's quickly take another example. Now here another question on board, still on factors affecting resistance of a conductor or a wire. And we already know the formula. R equals to rho A over L. Am correct? Rho L over A. Rho L over A. Now the question says the resistance of a wire of length 100 centimeters. That is the length of the wire. And the diameter is also given. The diameter of the wire is given. It's found to be 3 ohms. So the resistance of the wire of length, which was this, and the diameter, which was this, the resistance was this. Now you are asked to calculate resistivity. Resistivity, which the formula was, arrow A over L. Arrow A over L. Let's pick our variables here. Our first quantity that was given was length. Length was 100 centimeters. Now, the diameter was 0.3 millimeter. While resistance was given to be 3 ohms. So 3 ohms is in the SI unit for resistance. So let's quickly convert other units so that they will align to be in SI unit. So 100 centimeter is not in the SI unit. We have to convert it to meter. To do that, we simply divide it by 100. 100 divided 100, which will now give us 1 meter. We are good about the length, which is now in 1 meter. Now this diameter is don't want it in millimeter, we want it in meter. So we will divide it by 1000. 0.3 divided 1000, which is standard form, is 3 times 10 raised to the minus 4 meter, or 0.0003 meter. Now we now have it in meter. Mind you, our area was not given, and as we know, to get area will not be pi arrow square. But we don't need diameter, we need radius. So we'll get our radius for diameter. Arrow will not be d over 2. And our diameter was given to be 0.0003 over 2. So arrow will be 0.0, which will give us 1.5 times 10 raised to the minus 4 in standard form. With that, you have everything you need. Now this formula rho equals to arrow A over L. We'll now write it. Since A is not given, we'll write it as arrow times pi arrow square over L. A has changed to pi arrow square, which is area of a cycle. Now, moving further, we have the arrow was given to be 3 times pi, which is 22/7 times, because our arrow is carrying the square, and we're writing it inside the bracket. Our arrow is 1.5 times 10 raised to the minus 4 square. Arrow is carrying square over our length is given to be 1. So anything divided by 1 is still that same number. We are omitting 1. 3 times 22 is 66/7. If you square this, when you square that, you will get 2.25 times 10 raised to the power minus 8. Times this with this and dividing it by 7. Times it with 66 divided by 7. We will arrive at arrow is equal to 2.12 times 10 raised to the minus 7. So that is the resistivity of that wire. That is the resistivity of that wire. Let's not forget the unit, which is what? Ohmmeter. Now we are done with I. The other part is what is the conductivity of the material? Let's not work on what we have done. We say conductivity is related to resistivity, which was given as conductivity is equal to reciprocal of resistivity. This is our resistivity. 1 over resistivity. The conductivity is equal to 1 over resistivity of the reciprocal. 1 over our resistivity, which we have calculated, is 2.12 times 10 raised to 0.07. Now, 1 divided our answer will give us 4.713. So 3 decimal place. Now let's not forget our units. I have not mentioned the unit of conductivity. The unit of conductivity is still similar to that of resistivity. Ohm meter. Only that is carrying raised to minus 1. That is ohm